Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today we're diving into a paper titled Let Androids Dream of Electric Sheep, a human-like image implication understand.
Sounds intriguing. I'm always interested in how we're trying to bridge the gap between human understanding and machine comprehension, especially when it comes to something as nuanced as image interpretation.
I'm a bit skeptical, to be honest. The title itself is a bit much. Can we really get androids to understand image implications in a human-like way? Seems like a really high bar and a lot of overpromising in the field these days.
Yeah, I tend to agree with that sentiment. Human-like is the key phrase there. Are we talking about just replicating the output, or are we talking about actually understanding the underlying relationships and context? Big difference. What exactly are image implications anyway? Seems vague.
Right, so let's unpack that a little. As I understand it, image implications in this context refers to the ability to go beyond the literal pixels in an image and infer things about the scene, the context, the potential actions and intentions of the entities within the image. Think about seeing a picture of a child holding an ice cream cone that's melting. A human instantly understands the implication that the child is probably feeling happy, maybe a little stressed about the melting ice cream, and that it's likely a warm day. Can an AI system deduce those things?
Okay, that makes sense. So it's not just object recognition, it's understanding the relationships between objects and the implied narratives within a visual scene. Like if you see a photo of someone standing next to a broken vase, you infer they might be responsible, or at least involved in the incident somehow. I guess the paper is trying to build a system that can do that.
But that requires so much background knowledge. An AI needs to know about children, ice cream, melting feelings. That's a huge amount of information to encode. And how do you represent the feeling of stress in a way that an AI can understand and apply to different situations?
Exactly. It's not just about recognizing the objects, it's about understanding the cause and effect relationships, the temporal dynamics. The ice cream is melting because it's warm, and that causes a certain emotional state in the child. That's spatiotemporal reasoning, isn't it? Current AI has a hard time with that.
Precisely. And the paper, I think, attempts to address this through a combination of techniques. They're not just relying on a single deep learning model. They're trying to integrate different modules that handle different aspects of the problem. From what I read, they use a convolutional neural network for initial image analysis, object detection, and then they feed that information into a more symbolic reasoning engine to infer the implications.
So a neuro-symbolic approach. That's interesting. So the CNN extracts the features, and then something else tries to make sense of them in a more structured way. I wonder how effective that is in practice. I mean, how well do these two systems actually integrate? Is it a seamless handoff, or is there a bottleneck in the translation between the neural network output and the symbolic reasoning input?
That's always the challenge with neuro-symbolic systems. Getting the two parts to talk to each other effectively. Deep learning excels at pattern recognition, but it's terrible at abstract reasoning. Symbolic systems are good at logic and deduction, but they often struggle with the messy, uncertain data that comes from the real world. Marrying the two is a real art, and often doesn't work as well as you'd hope.
And I still think the problem is deeper than that. Even if you get the CNN to perfectly identify the objects and their attributes, and you have a flawless symbolic reasoning engine, you're still missing the crucial element of understanding the underlying physics and temporal dynamics of the scene. The melting ice cream isn't just a static object, it's a process unfolding in time. How do you represent that dynamic process in a way that the AI can reason about it?
Well, the paper touches upon that. They use something called a situation calculus to represent the state of the world and how it changes over time. It's a symbolic logic framework that allows them to model actions and their effects. So, for example, they can represent the action of being in a warm environment and its effect on the state of ice cream as melting.
Okay, that's interesting. Situation calculus. So they're explicitly encoding knowledge about how the world works. That's a step beyond pure data-driven learning. But how do they deal with uncertainty? The real world isn't always so clear-cut. Maybe the ice cream is melting slowly because it's slightly warm, or maybe the child is holding it in a special insulated wrapper. How does the system handle those edge cases and probabilistic scenarios?
Exactly. And that's where the symbolic approach often falls down. It struggles with ambiguity and incomplete information. It needs clearly defined rules and facts, but the real world is full of exceptions and fuzzy boundaries. You can't just encode every possible scenario in advance. It's not scalable.
And again, it's about coordinate systems. The warm environment is a spatial coordinate. The melting is a temporal coordinate. The child's stress is an abstract emotional coordinate. How does the system translate between these different representations? I bet they're treating them as separate, independent entities, instead of recognizing that they're all interconnected aspects of a single unified experience.
That's a really insightful point, Donald. I think you're right. The paper, from what I can tell, focuses more on establishing the relationships between these entities rather than truly integrating them into a unified representation. It's more like a series of logical deductions based on separate pieces of information rather than a holistic understanding of the scene.
So let's say the system correctly infers that the child is likely feeling stressed. What does it do with that information? Does it just output the word stressed? Or can it use that understanding to predict the child's future actions? Like, maybe the child will try to eat the ice cream faster or ask for a new one. Can the system anticipate those behaviors based on its understanding of the situation?
That's the million-dollar question. Can it generalize? Can it apply its understanding to new unseen situations? If you show it a picture of a spilled glass of milk, can it infer that someone is probably upset, even though it's never seen that specific scenario before? That's where the true test of intelligence lies.
And it all comes back to spatiotemporal reasoning. The spilled milk is a spatial configuration that changes over time. The emotional response is linked to that event in a specific temporal context. The AI needs to understand that connection, not just as a static rule, but as a dynamic process that unfolds in time and space.
Okay, so we've identified some key limitations: the lack of true integration between neural and symbolic components, the difficulty of handling uncertainty and ambiguity, and the absence of a unified spatiotemporal representation. So what are some potential research directions that could address these issues?
From my perspective, I think we need to focus on developing more robust and adaptable knowledge representation schemes within deep learning models. Instead of just relying on raw data, we need to find ways to incorporate structured knowledge and symbolic rules directly into the network architecture. Maybe something like graph neural networks that can represent relationships between entities more explicitly.
I agree that we need better knowledge representation, but I'm still skeptical that deep learning is the right foundation. I think we need to explore alternative computational models that are inherently more symbolic and structured, but also capable of learning from data. Maybe something inspired by Bayesian networks or probabilistic programming languages.
I think we need to completely rethink how we represent time and space in AI systems. We need to move beyond treating them as separate dimensions and develop a unified spatiotemporal framework that allows for seamless translation between different coordinate systems. Maybe something inspired by physics, like a space-time manifold.
And from my perspective, drawing inspiration from neuroscience, I think we need to focus on creating more biologically plausible architectures that mimic the way the brain integrates information from different sensory modalities and represents the world in a dynamic, embodied way, perhaps exploring recurrent neural networks with attention mechanisms to model temporal dependencies and contextual awareness.
Okay, that's a good overview. I think another interesting research direction would be to develop better evaluation metrics for these kinds of AI systems. Instead of just measuring accuracy on a fixed set of images, we need to create more challenging and nuanced benchmarks that test the system's ability to generalize, reason, and adapt to novel situations, and maybe even use games as a testing ground, as I have said before.
Yes, I agree with Otto. Evaluation is key. We need benchmarks that specifically target the weaknesses of current systems, like their inability to handle ambiguity or reason about counterfactual scenarios. We need to design tests that force them to truly understand the underlying concepts, not just memorize patterns.
And the benchmarks need to explicitly test for spatiotemporal reasoning abilities. Show the AI a video of a complex event unfolding in time and space and ask it to predict what will happen next. Or ask it to explain the cause and effect relationships between different events in the scene. That would really put these systems to the test.
I think that's an excellent point. And to add to that, maybe we can draw inspiration from developmental psychology and create benchmarks that mimic the way children learn to understand the world. Start with simple scenarios and gradually increase the complexity as the AI system improves. Observe how it learns and adapts, and use that information to refine the architecture.
That's a fascinating idea. So, almost like an AI curriculum, starting with basic concepts and gradually building up to more complex ones. And maybe even using interactive environments where the AI can actively explore and experiment rather than just passively receiving data.
The problem is, a curriculum assumes we know the right sequence of concepts to teach. What if the AI needs to learn things in a different order? What if our preconceived notions about how intelligence develops are wrong? We need to be careful about imposing our own biases on the learning process.
And that's where the spatiotemporal framework comes in. If we can create a unified representation of time and space, the AI can explore the world in a more flexible and adaptable way. It can learn the relationships between events in any order, because it has a fundamental understanding of the underlying physics and temporal dynamics.
And going back to the neuroscience perspective, perhaps we can use brain imaging techniques to study how children's brains develop and learn to understand the world. We can then use that information to inform the design of our AI systems. Maybe even create AI systems that can predict brain activity during different cognitive tasks.
That's a really ambitious goal. But if we could pull it off, it would be a game changer. Imagine an AI system that can not only understand the world, but also predict how our brains will respond to different stimuli. That would have huge implications for everything from education to medicine.
It's also a bit of a black box, though, isn't it? Even if we can predict brain activity, does that mean we actually understand what's going on? Correlation doesn't equal causation. We need to be careful about drawing too many conclusions from brain imaging data.
And again, it's about translation between coordinate systems. The brain activity is one coordinate system. The cognitive task is another. The AI needs to be able to translate between these two representations in a meaningful way. Without that, it's just pattern matching.
Right. So to summarize, we've discussed the challenges of creating AI systems that can understand image implications in a human-like way. We've identified some key limitations of current approaches, including the lack of true integration between neural and symbolic components, the difficulty of handling uncertainty and ambiguity, and the absence of a unified spatiotemporal representation. And we've proposed some potential research directions, including developing more robust knowledge representation schemes, creating better evaluation metrics, and drawing inspiration from neuroscience and developmental psychology.
Yeah, I think that's a pretty comprehensive overview. It's clear that we still have a long way to go before we can create AI systems that truly understand the world in the same way that humans do. But I'm optimistic that we're making progress and that by combining different approaches and drawing inspiration from different fields, we can eventually get there. I think more data will solve it.
I remain unconvinced. I think we need to fundamentally re-architect how AI works from the ground up. It might be a very long time and may not be achievable using current tech.
Well, I am confident that we'll get there, but the path won't be easy. It will require a fundamental shift in our thinking about intelligence and a willingness to explore new and unconventional approaches. This is why I will keep pursuing research on spatiotemporal systems to better translate coordinate representations.
Exactly. It's going to require collaboration, interdisciplinary thinking, and a willingness to challenge our assumptions. But I am confident that with continued research and innovation, we can unlock the secrets of intelligence and create AI systems that can truly benefit humanity. That's all for this episode of Cognitive Spirals. Join us next time as we explore more fascinating topics in the world of consciousness, cognition, and machine intelligence.